Hello students, welcome back to all. So, in our previous class, we discussed about the Sommerfeld's elliptical model as well as quantum mechanical model, right? So, in this class, we are going to discuss about quantum numbers. So, what are quantum numbers and what is the use of it? How the quantum numbers are useful to us. So, let us see. So in last class we discussed that finally the quantum mechanical model of an atom is proposed by the scientist called Erwin Schrödinger, right? So according to him, he proposed one more concept, that is orbital. So what is an orbital? So orbital means the region or space around the nucleus where the probability of finding an electron is maximum, that is called orbital. Which means around the nucleus we can't find the exact position of an electron, but we can assume where it is the probability is maximum. So according to Erwin Schrödinger, right? So now let us see quantum numbers. So quantum numbers are nothing but, these quantum numbers are used to identify the exact position of an electron. So these quantum numbers are used like just like address of an electron. So to find where the electron is located in an atom, we can't find easily. So with the help of quantum numbers only, we can find where the exact position of an electron in an atom, where the electron is located generally. So this is an atom, the electron is revolving in the outermost shell. So where the electron is there? So basing on the quantum numbers, so there are mainly 4 quantum numbers are there. So by knowing all the quantum numbers, we can find the position of an electron, right? So let us see what are the quantum numbers. So here there are 4 quantum numbers are there, we know. So the first one is called principal quantum number. So very important quantum number. So who proposed this principal quantum number? So the scientist called Niels Bohr proposed the principal quantum number, right? And one more point is there. This principal quantum number is denoted with the letter small n. So this indicates the orbit or shell, which means, see, according to the Niels Bohr, he told that the electron is revolving around the nucleus in a particular shell or orbit. So there are number of orbitals are there. These are called stationary shells or orbits, which means in the stationary cells the electron's energy remains constant. So he named the orbits also. This is the first shell and second shell, third shell, fourth shell, and so on up to infinite. So this number 1, 2, 3, 4 and so on. So this number is called the principal quantum number, which means the small n indicates how many number of orbits are there in an atom. So this is represented with the small n. And also its value is having the positive integer and starting from 1, 2, 3, 4 and so on up to infinite. So the principal quantum number having the values positive integers. First shell, second shell, third shell, fourth shell, like that up to infinite. And also this principal quantum number indicates the energy of an orbit also. See here, if suppose if n is equals to 1, so that is called K shell, main shell, K shell. So if n is equals to 2, which means that is L shell, means that is second orbit or second shell. If n is equals to 3, that is M shell. If n is equals to 4, that is N shell. So in this case, if the n value increasing like this 4, 5, 6 and so on means, if the n value increases means the size of the atom increases and energy of the shells also increases. So here the principal quantum number gives the size and energy of the stationary shells or orbit. That is very important point. Size and energy. So in your examination there is a question, it may be like this. Which quantum number indicates the size and energy of an atom or orbit? So that is nothing but the principal quantum number only. So this is the first quantum number, fundamental quantum number. So basing on the principal quantum number only, the remaining quantum numbers we can understand. So if n value increasing means the size of the atom also increases because number of shells are increasing, right? So the size of the atom increases and the energy of the orbits also increases. In last class we discussed while explaining the Niels Bohr's theory, what he explained that. So in the Bohr's theory, each orbit, so first shell having certain energy and second shell having certain energy. So each shell having definite energy and the energy is also having an order, which means, for example, E1 is the energy of the first orbit and E2 is the energy of the second orbit and E3 is the energy of the third shell and E4 is the energy of the fourth shell, like this. And the energy must be in this order only because the first shell having lower energy when compared to second shell and second shell having lower energy when compared to third shell, like this. So this is what about the principal quantum number. Principal quantum number is proposed by the scientist called Niels Bohr and it is represented by the letter small n and having the positive integers values from 1 to 3, 4 and so on up to infinite. Especially these cells indicates the orbit or shell. This quantum number indicates the orbit number. So if the n value increases means obviously the size of the orbit, size of the atom increases and energy also increases. So this is very important point. So energy order must be like this. So this is all about the principal quantum number. Now let us see the second quantum number. Now let us see how the azimuthal quantum number is there. So in Sommerfeld elliptical model, in last class I explained that if n is equals to 1, which means it is having only one circular orbit and its L value is 0, right? If n is equals to 2, it is having one circular orbit and one elliptical orbit, right? So here L is equals to 0, L is equals to 1. According to Sommerfeld theory, he introduced one elliptical orbit from second cell, right? To the Bohr circular orbit, he added one elliptical orbit. So because of adding this elliptical orbits only, he explained the fine spectrum of hydrogen atom, right? So here, if n is equals to 3, which means L having 3 values, L is equals to 0, L is equals to 1 and L is equals to 2. If n is equals to 4 means L having 4 values, L is equals to 0, L is equals to 1, L is equals to 2 and L is equals to 3. So like this and so on. Which means what happening here? So here L value is 0, which means for the first shell only L value is 1, which means here only one orbital is present, one subshell. So this is called orbit, subshell or orbital. So I will explain what is difference between orbit and orbital, okay? So here for L is equals to 0, so it indicates S orbital. If L is equals to 0 and L is equals to 1, for L is equals to 0 S orbital, for L is equals to 1 P orbital. If L is equals to 0 means S orbital, L is equals to 1 means P orbital, L is equals to 2 means D orbital. L0 S, P, D and F, which means the azimuthal quantum number is explaining about the orbitals. There are 4 orbitals, S, P, D, F, G and so on. Like this orbitals are there. So S orbital, P orbital, D orbital, F orbital, G orbital. Again it indicates what is the shape of the orbitals and how many orbitals are present in an orbit. So this azimuthal quantum number explains all those things. Why I am explaining this concept? Because by adding the elliptical orbits only we can explain the we can get the fine spectrum, right? So that is only here these are called orbitals or subshells. So this is explained clearly by the Sommerfeld. So this is called azimuthal quantum number. And I will give the complete details about the orbitals also. Okay. So now I will explain one concept. So if n is equals to 1, n is equals to 1 means that is K shell, right? So here K shell only L value is 0, which means only 1. If L value here if L value is 0 means that is S orbital. If L value is 1 means that is P orbital. If L value is 2 means that indicates D orbital. If L value is 3 means that indicates F orbital. So here for first K shell it is L having only one value, that is 0, which means here only one S orbital will present. If n is equals to 2, which means that is L shell. So L shell containing 2 subcells. So L is equals to 0 and L is equals to 1. For L is equals to 0, that is 2s orbital. For L is equals to 1, that is 2p orbital, right? If n is equals to 3, which means that is M shell. So M shell containing 3 values, 3 L values, L0, L1 and L2. So L0 means 3s orbital, L1 means 3p orbital, L2 means 3d orbital, right? So if n is equals to 4 means that is N shell. So N shell is containing 4 L values. So L0, L1, L2 and L3. So 4s, 4p, 4d, 4f. So what we are observing here, which means so K, L, M, N, these are the circular orbits. So main cells. So these are subcells. So L0, L01, L012, 3 like this. Which means so these are called orbitals. So this concept is explained by the Sommerfeld. So here small l indicates the azimuthal quantum number. So here number of questions are there. So actually from structure of atom topic, this quantum numbers is very important topic, and you will get number of questions for competitive exams as well as board exams also. So for K shell, how many subcells are there? For a M shell, how many subcells are there? If n is equals to 4, how many subcells are there? Like this. So number of questions. So you have to remember L value is 0 for K, for S orbital. L value is 1 for P orbital. L value is 2 for D and 3 for F orbital. So here S orbital, P orbital for L shell. For M shell, 3 subcells. For N shell, 4 subcells. Like this number of subcells are there. So this is all about the angular momentum quantum number and azimuthal quantum number. And again the shapes of orbitals are there, how the shape of the orbital will change and how many electrons will present in each subcell. I will explain all the topics, okay? Don't get tension. So the third one is called magnetic quantum number. So actually this magnetic quantum number is very simple, but everyone getting difficult for it. See, I will explain clearly. Just watch carefully. This magnetic quantum number is proposed by the scientist called Lande, and it is represented with m, small m, or ml also. See, earlier I explained that the small l indicates the azimuthal quantum number, right? So the small l value is always depend upon small n value. N value means principal quantum number. In the same way, here also the small m value, which means the magnetic quantum number value, is always depend upon the azimuthal quantum number value. So what is the magnetic quantum number? Let us see. So for example, this is an atom. If suppose this atom is placed in an external magnetic field, what will happen? So this is the options of the magnetic field. So in absence of magnetic field, the atom will be like this. If it is placed in an external magnetic field, what will happen means the electrons present in a different subcells will orient in different ways. So depending upon their energies. So I will explain once again. By presenting an atom in an external magnetic fields, so the electrons present in a subcells, right, will orient in different directions. So basing on their energies, which means, for example, if the electron is rotating in this way, in absence of magnetic field, but in presence of the magnetic field, the electron will rotate in this way, or in this way, or in this way, which means the electrons which are present in the subcells will get orient in different ways. So depend upon their energies, which means the orientation very important. The orientation of electrons is explained through the magnetic quantum number. So this is proposed by the scientist called Lande. Is it clear? So the magnetic quantum number means while presenting the atom in an external magnetic field, the electrons which are present in the subcells means already you know, s orbital, p orbital, d orbital, f orbital, all these are orbitals. So each shell, m shell, k shell, l shell, m shell, n shell, each shell having some suborbitals. So k shell having one subcell, L shell having 2 subcells, M shell having 3 subcells, right? And N shell having 4 subcells. So these subcells, the electrons present in these subcells will orient in different directions. So basing on their energy, depending on their energy. So that is called magnetic quantum number. Okay. This is proposed by the scientist called Lande. And here already I told you, the magnetic quantum number ML value is always depend upon L value. And the magnetic quantum number values are extended from minus L to plus L, which means for example, if if m is equals to 1, m is equals to minus 1, 0. So the orientation will be in 3 directions. So that is why here the magnetic quantum number having 3 values, minus values, 0, plus value, means its values are extended from minus L to plus L. So once again I will explain clearly. So for example, its value is depend upon having a formula 12 plus 1. 12 plus 1 means here, if L value is 0, which means you can substitute the 0 here, 12 plus 2 into 0 plus 1, that is equals to 0 plus 1, that is equals to 1. Means if L value is 0, M value is 1, which means it is not the M value. Here the 1 indicates that M having 1 value. Is it okay? Which means the value is 0. Which means it indicates only one orientation. Only one orientation. So that is why its value is 0. For suppose, so listen carefully. If L value is equals to 1, what will happen? M value is equals to, so 2 into 1 plus 1. Substitute the L value in this formula, we get 3. which means here m having 3 values. What are those 3 values? So minus 1, 0, plus 1. Why we are taking these values? Because the m value is extended from minus L to plus L. Okay, that is why here m getting 3 values. 3 values means it is having 3 orientations, which means the electron present in the subcell having 3 orientations. So this is the magnetic quantum number. So don't confuse here. I will explain once again clearly. Okay. So for example, so s orbital. So s orbital, I will explain the orbitals, shapes of orbitals. Okay. So here I am explaining four orbitals, shapes and details. So the first one is called s orbital. So s orbital having spherical in shape. So very important points, friends. It is better to write down a notes. So s orbital having spherical in shape. So spherical means this is the spherical shape. X axis, y axis and z axis. So this is the spherical shape. So here for K shell, L is equal to 0. For L shell, L is equals to 0. For M shell, L is equals to 0. For N shell, L is equals to 0. For every main shell, L having one s orbital. L is equals to 0 means that is nothing but s orbital. So for K shell, it is 1s orbital because here 1 indicates the first shell. For L shell, that is 2s orbital. For M shell, 3s orbital. For N shell, 4s orbital. See here, for every main shell, it is having one subcell, that is 1s orbital for every main shell. So for the first shell, that is 1s orbital. Second shell, 2s orbital. And third shell, 3s orbital. And fourth shell, it is 4s orbital. So like this. So here 1s means, here 1 indicates the principal quantum number, right? And S indicates the azimuthal quantum number because S means here orbital. So it indicates the azimuthal quantum number. So this is all about the S orbital. Now let us explain the shape of p orbital. So now p orbital. So p orbital having dumbbell shape. So if L is equals to 1, that indicates p orbital. So for K shell, there is no p orbital. So it's very important point. For L shell, 2p orbital, which means 1p orbital doesn't exist. So for L shell, there is 2p orbital. For M shell, 3p orbital. For N shell, 4p orbital. Like this. Because for the first shell, there is no p orbital. So that is why 1p orbital doesn't exist. And all p orbitals having the same shape, dumbbell shape. Again here, one more point is there. So while this because of external magnetic field, in the magnetic quantum number, the Land explained that while presenting an atom or orbital, while presenting the orbital or atom in the external magnetic field, what will happen? The shape of the electrons present in the subcell will orient in different directions, right? So here the p orbital is orient in 3 directions. So that is why this p orbital is again having 3 shapes. Is it clear? So px, first orbital is called px, py, pz. So there are 3 types of p orbitals are there. So I will draw the structure also. So on x-axis, so this is px. So this is x-axis, y-axis, and this is z-axis. This is px orbital. So this is py orbital. So this is pz orbital. See here, px orbital, py orbital, pz orbital, all the 3 orbitals having the same energy. There is no difference in their energy. There is no difference in their shape also. All orbitals having dumbbell shape only. But their orientation is different. Is it clear? So according to magnetic quantum number, these orbitals are oriented in 3 different ways. So that is why px orbital, py orbital, pz orbitals will form. So p orbital, all p orbitals having the same shape, dumbbell shape. And here px orbital, py orbital, pz orbital all having equal energy. So that is why these orbitals are called degenerate orbitals. Very important points. So you will get more lessons on your higher classes regarding these degenerate orbitals. So what are degenerate orbitals? So degenerate orbitals means all orbitals having the same energy, equal energy. For example, px, py, pz. In the same way, d orbitals also split means they are also extended into 5. 5 types of d orbitals are there, and 7 types of f orbitals are there. So let us see. Now d orbital. So how the in presence of external magnetic field, how the orientation of 3 p orbitals are there. In the same way, there are 5 d orbitals are there. So there are dxy, dyz, dzx, dx square y square, and dz square. So here 5 orbitals are there. And one more point, the d orbitals are started from n is equal to 3 shell, which means from m shell only. Because L value is 2 only, there exists a d orbital. Means if L is equals to 3, that is d orbital, which means 1d orbital, 2d orbital doesn't exist. The 3 orbitals are started from the third shell, which means the 3d orbital will exist, but 1d, 2d doesn't exist. So very important point. So d orbitals are started from the m shell, n is equal to 3. So now let us draw the shapes of d orbitals. So this is dxy orbital on x and y axis. This is dyz orbital. So this is dzx orbital. And very important point, the d orbital is double dumbbell in shape. Very important. The shape of the s orbital is spherical in shape. The shape of the p orbital is dumbbell in shape. But the shape of the d orbital is double dumbbell in shape. See here, the loops are present. X and y, y and z, z and x in between the axis. For dxy, dyz, dzx. So here also you will get number of questions. For dxy orbital and dyz orbital, dzx orbitals, these loops will present in between the axis. Now let us see the shapes of, now let us draw the shape of dx square y square. So this is x-axis, y-axis. So here the shape of dx square y square, which means here the loops are or dumbbells are along the axis, and dz square. So this is z axis, orbital will be like this. So this is the shape of the dz orbital, dz square orbital. So this is all about d orbital. So once again I will revise. So d orbital is double dumbbell in shape. It is split. It is having 5 orbitals: dxy, dyz, dzx, dx square, y square, and dz square. I will draw all the 5 diagrams also. And one more point here: the d orbitals are started from m shell only, which means 1d and 2d orbitals doesn't exist. And one more final important point here: all the 5d orbitals are having equal energy, which means same energy. So that is why these orbitals are also called degenerate orbitals. Is it okay? So this is all about orbitals. And also one more point here: f orbitals are there. So f orbital is split into 7 types. Split means it is divided into 7 types. So what is the shape of the f orbitals? So in our 10th class standard there is no data about f orbital, so you need not worry about it. Just I will giving additional information. So f orbital is having 7 suborbitals, and the shape of the f orbital is 4-fold dumbbell. You just remember the name, 4-fold dumbbell. So p orbital means double dumbbell, d orbital means p orbital means dumbbell shape, d orbital means double dumbbell, f orbital means 4-fold dumbbell. So this is all about the shapes of orbit. So now I told you that s orbital, p orbital is 3 orbitals: p orbital containing px, py, and pz, d orbital containing dxy, dyz, dzx, dx square, y square, and dz square. So totally s orbital is 1, p orbital is 3, d orbital is 5, and f orbital is 7. So like this. So now earlier I told that m value, m means ml value, magnetic quantum number value, is depending upon small l value, 2l plus 1. So if L is equals to 0, then what is M value? 2 into 0 plus 1, that is 1. Which means M is containing one value and that value must be 0. Which means L value is extended from minus L 0 to plus L. Means magnetic quantum number value is extended from minus L to plus L. Very important, please concentrate. You will get lot of problems basing on this topic for competitive exams. Okay, so just concentrate here. So here the magnetic quantum number values are extended from minus L to plus L. So if L is equal to 0 means we are having one value and that value must be 0. Is it okay? Is it clear? If suppose if L is equals to 1, if L is equals to 1 means I am having 3 values, because 2 into 1 plus 1, that is equals to 3. So 3 means what are the 3 values here? Minus 1, 0, plus 1. Is it clear? Which means, one second, I will explain one more concept here. If L is equals to, just wait, F containing 7 value. If L is equals to 0 means only one value. If L is equals to 1 means it containing 3 values. If L is equals to 2 means it containing 5 values. What are those 5 values? Minus 1, minus 2, minus 1, 0, plus 1 and plus 2. Is it okay? If L is equals to 3 means it is containing 7 values. What are those 7 values? Minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. Are you following or not? See here, I will explain. Okay. See, if L is equals to 1 means that is s orbital, which means there is s orbital will present, that is where the value is only 1, that value is equals to 0. If L is equals to 3 means, if L is equal to 0 means that is p orbital, because of course m containing 3 values means if L is equals to 1 means that is nothing but p orbital. But here the m containing 3 values, because the orientation of orbitals will be like that. So what are those values here? So like this, -1, 0, +1. So px, py, pz. So -1, 0, +1. Is it clear? If L is equal to 2 means that is d orbital. So d orbital having 5 dxy, dyz, dzx, dx square y square and dz square, which means here these numbers are indicating the orientation of orbitals. Is it clear now? If L is equal to 3 means that is split into 7. So already I told you f orbital containing 7 suborbitals. So these are the values for f orbital, which means m, the magnetic quantum number indicating the orientation of orbitals in presence of the magnetic field. Is it clear? So m having 3 values means these values are indicating the orientation of p orbital. Px, py, pz. These 3 orbitals are oriented in magnetic field. So this data, I think this is more than enough for magnetic quantum number, and just trust friend, this is very useful for your competitive exams. So just keep writing all the notes, okay? Now finally we will discuss about one more concept, one more quantum number, and the last quantum number, that is nothing but the spin quantum number. So the fourth one is called spin quantum number. So what is the necessity of this quantum number? See, actually the principal quantum number indicates the size of an atom and energy of an atom, energy of an orbital, and the azimuthal quantum number indicates the shape of the orbitals, and the magnetic quantum number indicates the orientation of orbitals. And the spin quantum number, what is the use of necessity of this spin quantum number? Actually this spin quantum number is found by the two scientists called Uhlenbeck and Gaudsmith. Is it okay? And it is represented with small s or ms. So now let us see what is the necessity of this quantum number. Already while explaining the electromagnetic spectrum, line spectrum, all those things, I told you one point. So while observing the street lights, what we are observing in street lights? So it will gives yellow color flame, right? So this yellow color flame is due to the sodium vapor. I told you this point. Is it clear? So because of the sodium line spectrum, this is nothing but line spectrum. So different elements having different wavelengths, because of the different wavelengths only it exhibit different colors. So sodium giving yellow color flame because of its wavelength. So while observing this yellow light in a high resolution spectroscope, this yellow light is again having the doublet. Not only this one, so not only this metal, so many alkaline metals and alkaline earth metals also. So what are alkali metals, alkaline earth metals? We will discuss all those topics in the next unit, okay? So not only the sodium atom, but also alkali metals, alkaline earth metals, all of the metals showing the same property, doublet. So to account for such behavior of an element, the additional quantum number, spin quantum number, is proposed by the scientist called Uhlenbeck and Gaudsmith. So this spin quantum number is represented with ms and s. So what it indicates? The spin quantum number refers to two possible orientations of spin of an electron. So here it indicates the spin of an electron. There are two possible orientations for an atom, for an electron. For example, the electron will rotate in two types of spin. For example, this is an electron. So there are two possible ways are there. So first one is called clockwise direction. So second one is called anti-clockwise direction. So there are only two ways are possible. So clockwise, anti-clockwise. Is it okay? So clockwise means it is showing upward arrow and it is having the positive value plus half. Its value is plus half. And in downward arrow, in anti-clockwise, it is showing minus half in downward arrow, which means the spin quantum number indicates for every electron there are two types or two possible orientations are there, which means nothing but two spins orientations of spin of electron. So first one is called clockwise, for second one is called anti-clockwise. For example, so the electron will have two types of spins, clockwise spin, anti-clockwise spin. If clockwise direction we can indicate with plus half, for anti-clockwise we will indicate that minus half. So this is all about the today's class. So in this class we discussed about the four types of quantum numbers and what are the some theories also explained in this class. And one more concept is there. So now orbit, orbital. See, what is the difference between orbit and orbital? Let us see. So atom containing orbits. So this is an atom. So this is first shell, n is equals to 1, second shell, third shell. So here n is equals to 2, n is equals to 3, and so this is the fourth shell. Okay, this is n is equals to 4, n shell. So here orbit means the path of an electron where to revolve around the nucleus, which means this is the path to the electron revolve around the nucleus. So orbital means it is the space around the nucleus where the probability of finding an electron, which means orbital means the three-dimensional space. Orbit means it is only plane. So in which direction? For example, in this atom only the electron will rotate in this direction, in this direction, or in this direction, which means in three-dimensional space. We can't imagine at that particular time where the electron is rotating, where it is located. We can't imagine. So that space is called orbital, which means where the electron is located around the nucleus in three-dimensional space. So that is orbital. So orbit means the path. So this is all about the difference between orbit and orbital. Now I will explain some formulas which are useful for problem solving, and I in my previous video I do one video for quantum numbers, especially the questions are coming, how the questions will come for competitive exams. So if it is possible you can watch it. And now there are some formulas are there. So the number of electrons present in an orbital. So it is forgot to tell you. For s orbital, so there are possibility of presenting 2 electrons are there. So per p orbital, so p is again divided into 3 orbitals. So totally 6 orbitals are there. So 2 electrons, 6 electrons for p orbital. For d orbital, so d orbital is split into 5. Okay, so 2, 4, 6, 8 and 10. So totally 10 electrons. For f orbital, so totally 14 electrons. 1, 2, 3, 4, 5, 6, 7. So 2, 4, 8, 10, 12, 14. So totally 14 electrons are there. Which means the s orbital can having only 2 electrons. For p orbital, the maximum electrons are 6. For d orbital, 10. For f orbital, 14. Okay, now the number of electrons present in an orbital. So there is a formula 2 into 2l plus 1. So if L is equals to 1, so that implies 2 into 1 plus 1. So that is equal to 2 into 2 plus 1. So that is equal to 6. So for L is equals to 1 means that is p orbital. For p orbital, maximum electrons are 6. So if N is equals to 2, then we are getting 2 into 2 plus 1. So that is equals to 2 into 5. So 10 electrons. So for L is equal to 2 means d orbital. In d orbital, obviously the maximum number of 10 electrons are there. So this is one formula, of course, shortcut. Okay, one more point is there. 2n square. So this is useful for number of electrons in a shell. So number of electrons in a shell means 2 into 1 square. So 2. So 1 means first shell. In the first shell means K shell. In the K shell only maximum number of 2 electrons are there. Okay. If 2 into 2 square means 2 4 are 8. Means L shell. For L shell, the maximum number of electrons are there. So all these are useful for maths problem solving. And I will give you one tabular form to identify. Is it okay? So n value, L value, m value. Okay, n is equals to 1. It is only L value is 0, m value is also 0, and that is 1s orbital. If n is equals to 2, L having two values, 0 and 1. So M having, for 0, it is 0. For 1, it is having minus 1, 0, plus 1. So what are the three values here? So Px, Py, Pz. Which means this is 2s and 2p. If n is equal to 3, L having three values 0, 1, 2, which means 0, 3s, minus 1, 0, plus 1, 3p, minus 2, minus 1, 0, plus 1, plus 2, 3d. So like this. So like this, the values of n depend upon n and the values of m depend upon L. So spin quantum number is two values, plus half and minus half. So I think this is very enough, more than enough information. And final topic. So K shell, n is equals to 1, L shell, m shell and n shell. So n is equals to 2, n is equals to 3 and n is equals to 4. For K shell only 1s orbital is there. So this is 1s orbital. Here only 2 electrons will come. For L shell, 2s orbital and 2p orbital. So 2s orbital means only 2 electrons, 2p means 1, 2, 3. So n is equal to 3 means 3s, 3p, so this is 3p, and 3d. This is 3d. And n is equals to 4 means 4s, 4p, 4d and 4f. So like this, the quantum numbers are very helpful to find where the exact position of electron. So this is today's class, and please once again you just go through all the topics what we have explained today, and I make a video on quantum numbers basing on sums. So please watch it, and if you have any doubt you can ask me through comment section. And please like, share and subscribe my channel, and forward to your friends also. Thank you.